If you've ever worked with conveyors, you know the feeling, that constant nagging battle to keep the belt running straight. Well, today, we're going to cut right through all the noise. We're going to break down exactly why your belt mistracks and give you a clear, simple path to solving it for good. Does this look familiar? How many hours have you and your team spent just nudging and tweaking and pushing, only to come back a few hours later and see the belt has wandered off again? It is a massive drain on your time and your resources. But what if I told you that actually fixing it is way simpler than you think once you know exactly where to look?
Okay, let's stop right here for a second. This sentence, this is the golden rule. Seriously, if you take one thing away from this, let it be this. Every single pulley, every idler, every roller, if it's rolling, it is steering that belt. Once you really truly get that concept, everything else just falls into place.
And here's the best part. No matter how big or complicated your conveyor system is, every single mistracking problem you'll ever have can be traced back to one of just two categories. That's it, just two. This simplifies everything. You're not looking for a needle in a haystack anymore. You just have to figure out which of two rooms the problem is hiding in. And here are the two rooms. On one side, you've got operating conditions. Think of this as the what you do category. These are the active things, right? Your processes, your daily maintenance, the way you load the belt. On the other side, you've got equipment conditions. This is the what you have category. These are the passive issues, the physical state of your hardware, its alignment, or the condition of the belt itself. So let's start by breaking down that first category. All right, section 1. So the first place you should always look is at what you and your team are actually doing at day in and day out. And the great thing is, these are often the easiest problems to fix because they usually involve changing a procedure, not swapping out some expensive piece of equipment. We're going to focus on 4 of the biggest operational culprits: rollers getting dirty from carryback, rollers that have just stopped rolling altogether, the way you're loading material onto the belt, and a surprisingly common one: issues with your skirt boards. Remember our golden rule? Well, for a roller to steer correctly, it has to be clean and uniform. When material, we call it carryback, builds up on a roller, it's like creating a little mountain on one spot. It effectively makes the diameter of the roller bigger right there. And the belt? It's always going to try to climb to the highest point. So it steers itself right toward that buildup and off-centered. This right here is why having well-maintained belt scrapers is absolutely crucial. Now, this one is a direct violation of our number 1 rule. If a roller isn't rolling, it isn't steering. It's that simple. It just becomes a point of friction, creating a ton of drag and throwing the whole system out of balance. The belt is just going to go wherever the other forces happen to push it. You'd be amazed how many headaches can be solved with just a quick walkthrough, looking for idlers that have stopped spinning. Okay, improper loading seems pretty obvious, right? If you dump everything on one side, the belt's gonna move that way. But segregated loading, now this one is a little sneakier. Let's say you have mixed materials. As the belt moves and vibrates, the little fine particles settle to the bottom, and the bigger chunks kind of work their way to the top and sides. This creates a hidden weight imbalance that you might not even see, and that can absolutely cause mistracking. This is a classic, a textbook case of a good intention causing a bad outcome. You see some dust or a little spillage, so you do the right thing. You go and tighten the skirt board. But if you tighten one side just a little more than the other, you've just created a break on that side of the belt. That extra drag slows that edge down, and the other side, which is moving faster, just pulls ahead and steers the belt right off course. Okay, so we've covered the operational side of things, the stuff you do. Now, let's flip the coin and shift our focus to the equipment itself. These are the issues that are quite literally built into your conveyor system's physical structure. And in this bucket, we're going to tackle 4 major equipment failures: basic misalignment, splices that weren't done correctly, issues with the belt's actual shape, like something called camber, and then problems where the belt just isn't even touching the rollers anymore. And here we are right back at our golden rule. Think of your main pulleys, your head, tail, and take-up pulleys, as the primary steering wheels of your conveyor. It's like the alignment on your car. If they aren't perfectly square to the direction you want to go, the car is not going to go straight. It's the exact same principle here. The belt will always try to run at a 90-degree angle to those misaligned pulleys. Okay, this one is huge, and it's a trap that so many well-meaning maintenance teams fall into. When you need to cut and splice a belt, the natural instinct is to grab a big framing square and put it up against the edge of the belt. But here's the dirty little secret. The edges of conveyor belts are almost never perfectly straight from the factory. So if you square your cut from a wavy, imperfect edge, you are permanently building a tracking problem into the belt itself. So what's the right way to do it? You have to completely ignore the edges. Instead, you find the belt's average center line. And it's pretty simple. You just measure in from both sides at a few different spots, make some marks, and then snap a chalk line connecting them. That center line becomes your true straight reference point. You square your cut from that line and you'll get a perfect 90-degree splice every single time. So what on earth is camber? Well, put simply, it's a banana belt. The belt has a permanent curve built into it, meaning one side is literally longer than the other. And a huge cause of this is just bad storage. If you take a heavy roll of belting and just leave it sitting on the concrete floor, its own weight can crush the bottom, stretching it out and creating that permanent camber. That's why proper storage racks are so critical. So how much curve is too much? Well, there's actually an industry standard for this. The maximum acceptable tolerance for camber is a deviation of 1 inch over a 100-foot length. So if you roll your belt out on the floor and it curves more than that, it's failed, and it's probably never going to track correctly. Now, for our golden rule to work, the belt actually has to touch the rollers. But sometimes issues like belt cupping, which can happen from too much tension or heat, can cause the center of the belt to lift up. Another problem is called junction joint failure, where the belt kind of forms an M shape and loses contact. In either case, if there's no contact with that center roller, there's no steering. It's as simple as that. Okay, we've covered a lot of ground here, right? We've looked at the two main causes, operations and equipment. So how do we put this all together into something you can actually use? Let's boil it all down into a proactive diagnostic checklist. And here it is. This is your new cheat sheet for troubleshooting. The next time you see a belt start to wander, don't just start randomly adjusting things. Stop and run through this list. Check your operations first. Are my rollers clean and are they all spinning? Is my load centered? Then check your equipment. Are my main pulleys aligned? How is that last splice cut? Is the belt even making full contact? This systematic approach will lead you directly to the root cause every time. And really, that brings us to the most important question of all. Constantly adjusting a mistracking belt is reactive maintenance. You're just putting a Band-Aid on the symptom. Understanding these root causes allows you to completely shift your strategy. It empowers you to build a proactive plan that doesn't just fix problems as they show up, but actually prevents them from ever happening in the first place.